All right, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. In the last video, we have established all the groundwork for printing the comparison results with the ASM printer. So we need to implement that now. Yeah. Good. Yeah. So now the question is, how do we want to print this? So we have a append to string. So we have a comparison. By the way, here. Comparison dot lines. Okay, so, the first thing we can print is comparison dot lines 0. I think for util strip, actually. Can we put a string view here? String view. String view. maybe this works. Okay, so the first line, get if lines instruction label. Oops. So this contains ASM label. ASM label. Symbol. Let's call this name. Name. You can also make it a string view. String view. ASM label pair. Okay, before we continue, we actually need to think about how do we want to display this. So let's open two boxes here again. Okay, so we have left and right assembler, yeah. How do we display it? Like, okay, we need spacing in between this thing. But then we have like long, eventually we have long names here in between. That is. Question is, how wide should it be? What do we do with long symbols? I think what we can do for starters, we so basically we need to, if you want to print it left to right, like right, then we need to determine like the spacing, right? So we need to count the spacing and then know our target padding. And if we exceed that, we would have to like truncate it, make a hard cutoff. So how long is this for starters? So this, so this is 52. So for starters, maybe we aim for something like 100. It's pretty long, 100. Well, maybe 80. Let's see. Let's make it a bit wider. So here at the bottom, we just type 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 10, 20, 30, 40, 50, 60. 60? Yeah, 60, 80. Okay, so this is 80. Can also make it a little bit more obvious. So this is 1, 2, 3, 4, 5, 6, 7, 80. Yeah. Oops, 80. Which is a respectable length, I would say, which is probably good enough for most instructions. There obviously will be some instructions which have super hardcore lengthy thingies, but just for printing as pure text, guess 80 is a good starting point. Yeah. We could also make this an option. Pentastring. Yeah. Okay, for now, let's do the const expr size t max max site length, then 80. To do make this configurable, max site len. Okay. So what we will definitely need is a truncate function. Let's make a private static truncate string. I think we can do it in place. No, we don't do it in place. Actually, we can truncate string in place. Void std string str max size maxlen size t and so that so basically if str dot size is larger than maxlen, then we simply say maxlen. Then we simply say str dot resize maxlen and while size t and that's p is maxlen minus 1. Let's not make it too complicated. Let's do maxlen equals std maxlen 2 size t max 2, and then we say str maxlen minus 1 equals dot and minus 2 dots. So the string ends on 2 dots to indicate that this has been truncated. Okay. Let's say end string on 2 dots to clarify that it has been truncated. Yeah. Okay. Truncate string in place. Good. Okay. Okay, I think the first thing we can do, the first variant is expected to be, the first line is expected to be a label. Name. Okay, We also need a function to add white space. Add white space. Yeah. Okay, how do we do that? Truncate string in place. Static void. Pet white space in place. Pet white space. str len. Here's some printer. Okay, pad white space. Yeah, so basically we have an str, and we have str, str. str pad count size t. Pad count is len minus if looking at this here right now. Once again, I don't like that we do this std max here. Basically, I want to protect against case when this would be 1, then this would crash, right? FSTS. Maybe we say if maxlen is larger than 2. If it's smaller than 2, then we can't truncate. I guess it's fine. Good. So here we say if str.size is smaller than len, then the pad count is len minus this, which will give us a number above 0. Const, and then we do for what we do following while wait, is there a function str dot insert of count char? We can use this. Is there an iterator version? This one. Count char. Yeah, this one we can use. Cool. Then that would be simple. Str dot end. Then the count, pet count, and the white space. All right. Yeah, that should work. Okay, that's simple enough. Pet white space in place. Yeah. Okay, cool. Okay, then we need okay. First line is expected to be a layer. Yeah. Okay. Okay, let's skip this here for starters. Yeah, let's worry about this afterwards. So what we want to do is we want to go through all lines. Yeah. ASM line vector, ASM line. Okay, it's a variance. Okay, so for const ASM lines, good. And then we say, why is this undefined? Huh? Oh. Oh. Okay. Some line vector. Well, let's take these out then. Here's some line. The name is a bit shitty. Is how about we call it ASM comparison line or comparison records. Comparison records. And then we call this ASM comparison records. And then we call this records. Okay. So we call this records. And then we can do here if count asm label, get if asm label record, then hold on, that's not quite right. Record. I'm actually surprised that this compiles, or that there's no wiggly line. I guess IntelliSense does not figure it out. Wait. Oh, it is a variant. That's actually legal. Yeah. Asm label. Yeah. So if it is a label, then we do something. Else if asm instruction then we do another thing. Else if there was asm hold on, that is not right. It's either label, match, or mismatch. Right. ASM match or ASM mismatch. Label, match, mismatch. Let's call it ASM label, ASM match, ASM mismatch. Okay. Good. So this is ASM match, ASM mismatch. Yeah. Else assert false. That cannot hit. Okay. Good. So if it is a label, then we simply what do we do? ASM label dot label pair label pair instruction label, ASM instruction label. So for size t, I equals 0, I smaller than ASM label pair dot size plus plus I. ASM label pair size. If SCD label pair I dot label dot empty, not empty. Label pair. Let's do std const std string label if not label dot empty. If not label dot empty, then const expr size t max total len should be max side len times 2 plus 4, I think. Well, maybe even I wonder ASM label instruction label instruction. Instruction label has no address. Doesn't need to have address. But we probably want to print addresses here in front. How long would these be? 0x 1, 2, 3, 4, 5, 6, 7, 8. We don't need the 0x. We just do like this. And then a space. Maybe 2 spaces. Two spaces. So 10. And then we have this here. Let's put ASM printer. Okay. Const expr size t. Let's call it max ASM len. And then we create a max or indent len. Let's put that at 4 characters. Indent len. Let's write it out with length. Len is good enough. Indent len, ASM len, total len, or let's call it line len. ASM len, line len, indent len. Then we also have the address len. Address len. Let's put that at 10. And ASM len. Line len. Okay, so So it will be 10 plus 4 plus 80 for one side. And then we also have a const expressity compare len. That will be 4 characters in my approximation. Okay, so that means we will have we will have 2 times address len plus indent len plus ASM len plus compare len. Yeah. But over here, I think we can hard code with 2. Let's put a const expressity side count equals 2. Put that here. And then side count like this. Okay, so this would be that. And put side count here. Make part of this configurable. Okay, so label. For records. Okay, so we have std string line. And we line dot reserve line len. Line dot reserve line len. Good. So line reserve line len line. Good. Good. So if not label pad white space. Okay, we need to be smart here. Label. If not label empty. What do we do if it is empty? Else, I think what we call is pad white space in place. If I equals 0, then line dot insert dot line dot end compare len 1 space. We could also, yeah, no, that's fine. Okay, so pad white space in place, else. No, we put that here. We don't need an else. Pad white space in place. That would be line dot, no, line and then oof. Line. It will be I times ASM len I plus 1 times ASM len plus I times compare len. No. Well, yes, that's correct, I think. Okay, and if it's not empty, then we do, if label is not empty, then line at, let's do append label dot we need to truncate. We need to truncate. But then we need to create a copy. But don't want to create a copy. Can we do it without? Shit. I don't want to create another copy. I don't know. It would be nice to just... shit. The string truncate. How do we truncate this without making another copy? I don't know. Actually, I have an idea. We create a std string buffer, and we just reserve it with a very generous size with 1024. buffer reserve. Yeah, that will work. Okay, so we do buffer equals label, and yeah, buffer equals label. Then we do truncate string in place, buffer, bugger. Buffer and asmlen buffer label, and we do buffer plus equal colon buffer asmlen truncate, and then line append buffer. Yeah, and then once all this is done, then we do records. Okay, I realize we probably don't want to reserve here. Instead, we want to say str.reserve comparison.records times, wait, str.size plus records times line dot size. Yeah. Good, and then we say here, we can also make this a buffer. So let's call this ASM buffer, and then we create a line buffer. Let's just call it ASM buff. And then we create a line buff. Okay, so we have ASM buff, line buff, and the line buff dot clear ASM buff dot clear let's do label plus this. This is not good. Let's keep it like this. Actually, let's make it a char. Okay, and then here at the end of the loop body, we do line str dot can also use plus equal here, or use pins. Dot the pins. Push back and assign. Okay, and here str dot append line buff. Okay, this should be pretty efficient. Let's put a breakpoint here. Okay, so we have buffers for the ASM instruction, then for the whole line, another buffer. We truncate the ASM buff. We build the line, right now only with the label. And then at the end, we append this to our str, which has also been reserved. And we have some error here, strip. Oh, we touched our strip function and somehow it is not correct. Strip, what is wrong? Strip, in place, const. Function definition for strip not found, but it's here. Oh, all right. Okay, good. Let's see how our loop is going. Good. So we have a buff here, and it is reserved with more. Okay, and 207. Interestingly, it over reserves. Well, that's fine. Good. So line count label. Yeah. So it's win main on both sides, very likely. Yeah. Not label empty. ASM buff label pushback colon truncate And then it should now add some white space, yeah. Okay, and how long is it? Size 80, yeah, okay. And then it should also add 4 more characters, so it should be now 84, yeah. Okay, and now it should add the other side. Boof. Yeah, Winman, yeah. Winman. Wait, hold on. 84 plus 80. 84 plus 80 is 164 or so. So 164 should be 163. Yeah, okay. Yeah. That should be correct. Yeah. One thing here, I wonder if this should be instead I smaller than I not like this. I not last, basically. Yeah, I think that is more correct. Okay, let's run this through. Let's see what it prints for now. Okay. Okay, it has a bunch of things printed here. Let's open this. Okay, we have a problem here. We forgot to add line breaks. That's a good point. Line breaks. Line length. Let's do a const expr string view line EOL equals n std string view EOL. So we put line length plus EOL dot size, and then here at the end line buff dot append. Can we append a string view? String viewish, yeah, probably. EOL append. Okay. Okay, let's test this out. So line length is now 193. 193. Address, indent. 10. Okay, let's run it. Let's see what it generates now. Mm-hmm. Mm-hmm. Yeah. So we are missing right now all the assembler code, obviously, in between, but this already looks the way it should. Yeah. Okay. Good. Then it's quite wide, isn't it? Yeah, you need a wide monitor for this. Yeah, I think it's fine. Yeah. Okay. Good. Next is next. Mm, well, ASM match and mismatch will be very similar. The only difference will be the symbol in between. So yeah, but we can worry about consolidating this later. Okay, so let's just go with match, ASM match. So we need this as well. Let's take this copy. So we have site count, we have label. No, we don't. This is ASM match, and this one will have instruction pair I and ASM instruction. Right, instruction pair. Label. Good. So I think we need to ASM instruction. Let's put here ASM instruction. Instruction. We need to dereference this. Okay, so if instruction, if it has an address, if address is not 0, because wait, let's see. Yeah, so 0 is the default. But strictly speaking, a 0 address strictly speaking 0, well, no, it's not a valid address. It's null point, null, can't be null. Yeah, let's go with not 0, should be okay for now. If instruction address is not 0, then what? Then let's delete this here. Then don't think we need this here. I think once this is done, we can probably str in str size, record size, line len. Yeah. Let's put another const express size t and count equals 4 and EOL count plus and EOL count times EOL dot size EOL count EOL. Oh, that doesn't work. Maybe it has to go here. STD insert, no, STD string inserts. Pause. Do we have something? A string view. But we can't say. But we can't give an iterator. That's weird. Maybe this here. And EOL dot begin, EOL dot end. That works. There we go. Okay. Okay. Comparison records. Comparison results. So this is, hold on. This is for one function, right? This thing. Yeah. Okay, so if instruction address is not 0, then we know it's an address that we would like to print. There are also like dummy addresses which will be 0 and then we print nothing. Actually, hold on, then we still have to do this thing here. Pet white space in place. And here we have to put append equals 4 characters. Let's put const expro std string view, oops, string view equals that equal and then unequal. Let's make it XX. Yeah. Okay, so indentlen is 4, comparelen is 4. So comparelen we say equal dot size. And here we do a static assert equal dot size is the same as unequal dot size. Expects same length. Okay. Okay, so then here we append the equal and line buff is comparelen, yeah. And here we then put I would say we do asm buff dot assign. So first we need empty to string. fmt format. Um, 8x 08x, I think. I'm not sure. And we give it instruction address. Instruction address. Okay. Then, no, that is line buff. We put the line buff. Then line buff. Line buff. Append. Okay, then we do ASM buff dot assign instruction dot da, 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 da. 0x bytes. 08x. So let's put it small. 08. Let's put this thing here in here. How long is this? Can't see. 61. Maybe we can shorten this. How about we make this a standalone function and this as well. This way we can reuse it here in this function because we need that as well, not just here. Yeah. Oh my gosh. Okay. So we need a function. Some instruction. Yeah, instruction label. So we do static void, no, static std string to string const asm instruction label. There we go. And asm instruction as well. Instruction. Okay. Then so the static asm printer. I want to 1, 2, and oops. So this guy will do print instruction. But this one has here this. Okay. Print label to string. So we do return. Why is there's so much red here? Why is there so much red? Text. Strip quotes. So a lot of string allocations on here. If we do this, so every time it calls toString, it allocates string here, returns it, destroys it. I would do it anyway here. This format. Yeah. Yeah, I don't know. Okay, str return str string. Oh, what's that bullshit? Label dot label. Instruction dot jump. Instruction jump then. Add unrecognized instruction as comment. Print instruction. Why is this comment here? I should put it here, right? Strip quotes. Looks like we need to put that here. Okay. Good. So here we can assign. I don't wonder we should std move it. Maybe. Can we do that? I don't know. Std move. I'm not sure. I'm not sure that is legal. Maybe. Maybe. Yeah. Basically, avoid reallocating if not necessary. Move it. I mean, here we have to allocate, but it's rare, so it's fine. Yeah. Yeah, let's try this. Okay, but here we have a problem. We have a fixed indentation. Well. Let's put a size T indent. To string indent. Yeah. Indent len. So we say str.insert print instruction as str.reserve indent len dot indent len dot no plus std string text okay text how about we do a strip in place? Text. Strip in place. Text. So we do text dot reserve indent len plus instruction text. Okay. And then we do text dot no. Then we do util strip in place text dot size. Then we strip in place. And then we do text dot insert text dot end and indent len space, and then we do text dot append no, then we put this here, text dot append instruction dot text, and only afterwards we strip the quote from it. Strip in place. str erase, yeah. Yeah, this should be, so this should be how many allocations? This is one allocation here, this is allocation. Then we insert, append, so it's just one allocation this here. Okay, that's fair. That's fair. Okay, let's remove this. But then here, this will be second allocation here, plus. Is this also an allocation? Don't think so. This should be fine, okay. And this is... I don't know if std move is legal here. Let's remove it for now. Let's not risk it here. Hold on, why do we use text here? We should use str. Yeah, there we go. Okay, so this is at least one allocation. This is an allocation here. And there's maybe two allocations. Yeah, definitely two allocations. So this is the first and then the second if it is jump. Yeah, it's okay. That's okay. Actually, hold on. We could reserve extra if it's a jump. Plus size T jump reserve it's too complicated. Let's not do that. Just allocate twice. Keep it simple. Okay, let's put a breakpoint here so I actually see it's correct. Okay, and then we can now use these to str plus equal to string so indent len here. To string label and here print label str plus equal to string instruction and indent len. There we go. Do we really need this comment here? Print assembler text. Prints unrecognized. Or append jumped. Thyme. Okay, it's pretty simple. Oof. Well, I have to say, this printing is not as easy as I initially hoped, but it is taking shape. That's some pun. Okay, line buff append, format, instruction address. Good. ASM buff. So this here we need to string now. Actually, hold on. We ASM buff here. We also let's do ASM buff equals to string. Let's put here ASM instruction label. ASM label, I think. No, instruction label. We should rename this ASM label. Like it's kind of confusing. You have a ASM label and ASM instruction label. I don't know. Okay, so label dot label. So if not label dot label empty to string label is above to string label. Okay, so string. Okay, line buff pens. Okay. Okay, to string instruction with indent len and then we need to truncate that. Truncate ASM len, okay, and line buff append ASM buff. Okay, so we so we appended the instruction address. Instruction address len, then indentation, then ASM len. I think here we have a mistake. ASM len. I think here ASM len needs to be to string truncate string. Okay, here line buff line buff dot insert line buff dot end address len spaces, right? Pad white space in place. So this needs to be ASM len plus, we need address len plus indent len plus that, right? I plus 1 address len plus indent len plus ASM len plus I think so. Oh boy. Okay, I think this might be correct. Maybe. Yeah. Let's run this. Let's see. Okay. Okay. Yeah, this looks correct to me. Yeah. Yeah. This looks correct. I mean, we are still missing here one entry, but yeah. Yeah, this looks good to me. It's a bit tricky with the indentation and everything to get it right, but this looks solid. Okay, now the question is, can we, so we would have to copy this and then do pretty much the same thing, except for this. This would be different, otherwise it would be the same. Should we consolidate these guys into functions? Let me see, what would be the inputs? There would be buffers, line buff, ASM buff. Pad white space. Can we consolidate this in place? We have an instruction. I mean, we could call a function here for this, but maybe we can do it differently. A lambda. ASM buff, line buff. Line buff. Okay, for this we can create a lambda function, I think. Auto pad line equals that equals we do std string line buff site index size t site index pad this pad white space site index pad line, and then we just pad line pad line buff I pad line. Okay, that's already a little bit of simplification. Why is this not? Why is this complaining? Ah, there we go. Yeah. How do we? So basically, let's look at this. So we would put the same thing here, but the only difference would be here unequal. That would be it. And this. Yeah. Yeah, but maybe it's okay. I mean, it's not so big. It's not so big. Yeah, maybe it's fine. Yeah. Okay, let's see how this looks. I need some water. Okay. Okay, let's run this. Okay. Mm. Mm-hmm. Mm-hmm. XX. Actually, there is... Okay, so it already is here with look ahead. That's cool. Mm. I would say if we have instructions on both sides, we put an XX. But if we have instructions just on one side, then we put something like, I don't know, something like this. Maybe X, like so. I mean, we have freedom. We can design it the way we like. Maybe here X, maybe like so. I wonder if we should do it like that. Okay, we also have multiple functions here, I just see. Line URL. Okay, we should probably... Okay, I think for starters, we need more visibility that these are multiple functions, right? So it looks a bit dense, so there should be more spacing here. I would say we put behind every function we put 4. So we have this, and then we do inserts. EOL. And EOL count. For size T, I 0, I smaller than and EOL count plus plus I str dot append EOL. Okay, that is sorted. UL size. STR is record lens. Okay, so does a reservation make sense? Yeah, that's a big question. By the way, I also wanted to check. Oh, we already checked. I think there's still errors here in this reservation size, but we get to that. Yeah, okay, so a little bit more space, that's good. So basically here it's XX because there's nothing here on the side, right? Which is the way we have designed it with the look ahead functionality, right? Maybe if on one side is nothing, then there should be no XX. Maybe it should be just like 2 of these. Let's see. So we could say if so if so if let's put here next instruction is I plus 1, right? I plus 1. So if next instruction dot address I would say we add a function here. Bool is valid. No, it's is empty. Is empty. Return address equals 0. Is empty. So instruction is empty. If not, is empty. Where's the problem here? Cons. Okay, so if not is empty, and here if not is empty, and we say here if instruction address dot is empty, if not instruction address, if not instruction is empty, and not next instruction dot is empty, then unequal. Then we will append unequal. Unequal. Missing left missing. Let's say missing. Yeah, left missing. Right missing. Equals left missing dot size equals right missing dot size. Can we do that? Okay, for some reason this fails. Why? Are we not allowed to make a statement like this? They're all 4. What's the problem? Maybe we are not allowed to make a statement like this. I thought it would be possible. Well, maybe I'm wrong. Maybe we have to write it like this. Let's put the static assert here at the end. Okay. So if that, then else if instruction is empty and not next instruction not empty, let's call this right instruction, then left missing, else if not this and this, then it's right missing, else that shouldn't happen, unexpected, assert false. Now I got my keyboard all wet somehow. I don't know how that happened. That's probably the sweat. That's what the programming sweat. Okay. Can we write this better? It's a bit shittily written. Guess it's fine. Yeah. Maybe it's a bit complicated to read. Okay, but as long as it works, I guess it will be fine. Okay. Okay, let's see how that looks now if we print that. All right. Yes. Oh, that looks wrong. That looks extremely wrong. Why? I guess because we put this here. Okay, so it needs to be put here, actually. Let's see. Add line breaks at the end. Okay, yeah. Yeah, it's not bad. Maybe we move this here to the top. All right, and it's still wrong because we need to append EOL there. Let's make it on an extra line. str. Yeah. Yeah. Okay, there we go. That's better. Yeah, got some nice spacing there. Okay, so we now got this new symbol here showing that's only one side. Yeah, this is much easier to look at, I would say. Yeah, this is better. I like that. I like that. That's cool. Mm-hmm. Mm-hmm. Yeah, it looks really good, I would say. Here we have the truncation. Okay, but I'm curious. This is longer. Hold on. Can we see how much we select here? Yeah. Okay, so this is 76. Oh. Because this is 80. This is 80. Yeah. But then we have here 4 more. So there is something, we do something wrong here. Let me see. So basically the truncation should be longer. It should then, here should be the 2 dots, basically, here. And then it should be here a bit longer for more characters text. So something is, we do it wrong here. ASM buff. Because we indented here. Yeah, so the truncation. So we need to. Let's see. Okay, to string. So we do truncate ASM len plus indent len. Then that should fix it. Yeah. And here I think it's fine because the label is just ASM len. Yeah. Okay, this should be correct. Okay, what else is wrong? I have to say I'm really surprised like how good this actually works. Like it actually, to me it looks really, really good. I don't see any fault with like the comparison itself. That looks really solid. Yeah, sometimes I'm surprised about myself. Yeah. Now there is a little bit of a problem here with the imp thingies here. Imp. These things here. It will not recognize them as the same because the string is slightly different, but essentially it's the same thing. So we need to figure out like how we can get the symbols to the same string, but it's not a big deal, I guess. Okay, but this is definitely wrong, right? Compare word pointer. Here's EAX plus 4, and here's just EAX, right? No, the rest is the same. Yeah, it looks really, really good. Really nice. Okay, now the question is, right, there's one more thing. Apart from, let's sort the reserving first. Let's sort the reserving. Okay, because I think it's not yet quite right. Okay, let's put actually size t reserve len equals, let's make it const reserve len. So basically what we can do, if we really want to brute force this, we can put an assert here at the bottom. Assert str dot size equals reserve len, because we should be able, since we do the white spacing thingy, we should be able to get this spot on. Oops, clicked the wrong button. So Reserved len will be a generous amount, and my expectation is now that we don't hit that. Let's put a breakpoint here. So reserved len is 98627. 98627. Oh, it actually matches. Okay. I'm surprised. Okay, well, we got it right then. Good. Let's see if it ever hits. No, okay, that's right. That's correct right now. Okay, good. Yeah, well, no mistakes. We make no mistakes, right? Okay, so next step is at the beginning of the function, we can also print a little report. We can say good. Let's put this here back in. I need a short break. Hold on. We'll be right back. Actually, no. I'm back already. Okay. So we have name, label, ASM label comparison dot. What is it? Records. Records is 0, right? Yeah, actually, yeah. STR reserve. So what we can do is so basically in our comparison result we have these label count, match count, mismatch count. Yeah. So we can print let's put these guys here. Line buff. Let's put ASM buff. ASM buff equals FMT format match matches D and mismatches put it on a new line. Matches. Yeah. Mismatches. D. And percent. Match percent. D. Okay. N. Actually, it should be EOL. EOL. So. Okay. So we put EOL and comparison dot match count comparison dot mismatch count and another EOL here and percent let's make a F 02F just F const float match percent is comparison match count divided by mismatch count float times 100 dot F. I think let's so let's say we have 20 matches and we have 40 mismatches. Oops, scientific. 10 matches, 20 mismatches, 0.5 times 100, 50%. Well, that doesn't make sense. Match count. Match count plus mismatch count. I think that makes more sense. So let's say we have 10. Let's make const un32t instruction count is match count plus mismatch counts. Actually, we can make this a function in there. How about that? Comparison. Get un32t, get instruction count const return match count plus mismatch count. Okay. And so here is buff comparison. Hold on. Comparison instruction count. So divide comparison get instruction count. So this should be then correct. So let's say we have 10 mismatches and we have 20 10 matches, 20 mismatches. So it would be 10 divided by 30 and then times 100. So that would be 33%, yeah. So that get instruction count and actually I think we can remove this here. Yeah, remove that. Match percent F match percent. Yeah, matches, match count EUL, mismatches here, mismatch count EUL, match percent EUL, EUL. Okay. ASM buff. Yeah, and then we would also say plus ASM buff dot size. Yeah. ASM buff, and then here we would str dot append ASM buff. Okay. Okay, let's run this. Let's see what this looks like. I imagine that we need to print something above it. Otherwise it looks probably a bit a little bit detached from everything. Let's see. Okay, so it says matches, mismatches, match percent. Oof. Match percent. Let's do 01F, I think. Dot 1F. I think. I'm not sure. 1F. Yeah, I think it would be nice if we would have a label above here. But we have it here already, so you know, don't need it here. Maybe we should just have like a line here. Matches. Okay, how about we put it like so? I don't know if that's proper. Oh, it does work. That's cool. Yeah, we should do that. I don't know, should we perhaps... I don't know. It would be nice to have something here, because it feels kind of odd to start this block with this information. Okay, so, I mean, we know that the first line is supposed to be is above. Okay, let's take this name, label pair 0 dot label no label name unknown. So we just say code percent s no s s SSS. Okay, we put a name. We have done this thing here before. Name. Which percent? Yeah, let's put this down here. Okay. So we start with name and then EOL. Or maybe just put one EOL. Your name. Yeah, let's try this. Okay. So we have this string here without any trimming. And yeah. Maybe we should indent this a little bit. Or decorate it with some nice symbols. Yeah, let's put a colon. like so, maybe. Maybe like so. Okay. Yeah, maybe that's good enough. Yeah. Yeah, I think that's cool. Okay, let's check if now the capping works properly. Do we see something that is extra long? No, everything is extra short. Everything is extra short. Yeah, let's look at some other. Here, game memory. Yeah, looks pretty good. So a capped symbol. Here we have one. Yeah, that's perfect. Yeah, I think that's good enough. Yeah. In the UI, then we can make it draw the whole thing, but then you would have to scroll left and right. But here for texting, we need to cap it at a certain distance. Yeah. But if we make it configurable, then one can dial this how he likes it. Yeah. Yeah, I think that is. It looks pretty good. It looks pretty good. Yeah. So we have a bunch of files that have nothing in there. Yeah. Matches 84%. Matches, mismatches. Yeah. Mm-hmm. Yeah. Yeah. Okay. What about algo base? It's the same. Yeah. Okay, good. Then, yeah. Yeah. Then this ASM printer works in principle. Then yeah, what's the time? 2 hours 47. Yeah, we are ripe for a break, but let's zip this up here. 7 zip, debug zip. That's 85 kilobytes. Thyme game comp 1. Zero one. Okay, let's give a status update to our bros here. Implemented, finished implementing ASM printer. It works. Here are generated reports with what it currently does, what it currently can do. Functions are finished implementing. It works here. Generate reports with what it currently can do. Functions are bundled by PDB by the source files from the PDB, from the Thyme.pdb. Maybe you can also ASCII string. Let's add a sample here like this. Sample. Oof, we can't. Destroys it. Looks very good already, but we need UI. We need UI, I think. Also, still need to make links between the the matching between the addresses and source code. Need to show links between the addresses and source code. Looks decent. Looks decent. let's remove this obsolete information. Vulnerable source files from the server. Yeah. Good. All right, then I will take a break now. And next session, we will finalize what we currently have here staged and submit it. And then there are two big tasks left. One is linking the assembler instructions to source code, right? That, and either print that in a text file as well, but I don't know if that would be good. I don't know. And then the other big task obviously will be the UI, to like have ease of use with some UI buttons, inputs, and click things and stuff. What we can also do is still here make this configurable. This will be a small side task, yeah. But the UI task will be big because we need to figure out how to draw it. Yeah, then push all the data there instead of pushing it to files. Yeah. Good. So there's still plenty to do, but I'm already very happy with the results. Yeah, it looks promising. All right. I hope you enjoyed. I wish you a great day or night until next time. Goodbye.